For interaction of electron with a matter, firstly what you need to know is that which type of electron that causing further interaction with human tissue. Remember, from photoelectric effect we have photoelectron, and contact effect, the product is the recoil electron. So the electron that responsible for further interaction is coming from these two electrons, photoelectron and recoil electron. Okay, photoelectron and recoil electron. These two electrons is known as primary electron, because later on when we go a bit details, I'm going to introduce to you secondary electrons. So remember, the primary electron is coming from photoelectron and recoil electron. So the one that we've learned in interaction photon with a matter is actually the original site of atoms to produce electron. So what we want within that interaction is actually that electron that coming from photoelectric effect and Compton effect. These two electrons is causing further ionization and excitation. So if I'm taking, let's say, this one of the human tissue, we have a lot of atoms in single tissue, and X-ray is come in, interacting with single atoms and producing this electron. Then these two electrons, either photoelectron or recoil electron, interact with another atoms, producing either electron or either Bremsstrahlung, which we are going to cover later on. So generally, the interaction of photon with matter is actually to produce these two electrons, because these two electrons is the one that causing further interaction or deliver its energy to another absorbing mediums. Okay. Okay. So for interaction of electron with the matter, the interaction can be caused by two. Either electron will interact with electron, or electron will interact with the nucleus. So for electron that photoelectron or recoil electron interact with the electron, there are another two types of interaction happen. Either the energy is from radiative loss, or it can be collision loss. And for nucleus, it's actually this primary electron interact with the nucleus. It interact with the nucleus and just causing change direction without any loss of the energy. It's just a scattering process, which is not that much importance. The one that importance for this interaction is actually coming from here. So I have this diagram. The blue atoms here is mean the origin site of electron production, the origin site. Firstly, let's go to radiative loss. How we can differentiate between radiative loss or collision loss? Let's say I'm taking single atoms. After the incident of photons with the atoms, okay, this electron, after it absorbs energy, it will travel until at rest, where the speed is become 0. Okay, during the travel, this electron travel at certain length, so it will meet another atoms during the interaction. Okay, there is a lot of interaction within the a lot of atoms within the tissue, so it keep on interact until it becomes rest. So how we can know it is from radiative or collision is from this is the particle track or electron track from the nucleus to the particle track, denoted as B. From nucleus, the diameter from nucleus to the outer shell is known as A. So when this particle track travel and the B is greater than A, and then inelastic collision will occur. B greater than A, or is known as soft collision. If, let's say, it travel, the B is equals to A, what will happen? It becomes hard collision. And if, let's say, here, it is actually happen, let's say we have another electron passes through the nucleus until it becomes at rest. When it interacts close to the nucleus, the interaction happen is radiative loss. Okay, I repeat it again. If, let's say, the particle track is greater than A, then it will be soft collision. If B, the particle track B, is equals to diameter of the atoms A, then it will become the hard collision. But if, let's say, the electron, either recoil electron or photoelectron, interact close to the nucleus, then the interaction is a radiative loss. So what is meant by radiative loss or collision loss? The radiative loss is that the interaction of electrons with absorbing mediums. So this atom is known as absorbing mediums. This is the original atoms that produce the electron. Okay, this is the original atoms, and this is the absorbing mediums, absorbing atoms within the mediums. Alright, so the electron passes through the nucleus. The electron interact with the nucleus is known as the radiative loss, or B less than A. If you draw, the B here is less than A, then it will become radiative loss. So the energy loss is described as radiative stopping power, which we are going to go further later on. For collision loss, what is meant by collision loss? The interaction of electron with the outer electron of the particular atoms. So if, let's say, B is greater than A, then it becomes soft collision. What is meant by soft collision? The soft collision means that energy, electron transfer a small amount of energy to the orbital electron and causing excitation of these atoms. Okay, and then it will keep on continue travels until it meets another atoms and it becomes rest. So half of energy from particle tracks coming from here is transferred to this atom. Okay, so the energy loss is described as collision stopping power. And what about this one, elastic collision, or be known as hard collision? So between soft collision and hard collision, soft collision is most likely to occur compared to this one. Okay. For this one, if, let's say, the particle or electron travel, electron track interaction, the site of interaction B is equals to A, and then it will produce another radiation which is known as delta ray. This delta ray is secondary electron. So this secondary electron delta ray will have its own path. This is the electron path track until it comes to rest. For delta ray, it will create its own path, deviate from the original electron, and then it will stop until rest. This delta ray only occurs when the site of interaction B is equals to A. Okay. One more thing that I want to explain: when the electron interact close to the nucleus, it produces Bremsstrahlung radiation. Usually, this Bremsstrahlung can be negligible because it consumes very low energy. So overall of this interaction is actually when the radiation coming from the X-ray tube passed through the human body, attenuation process occurred, whereby which is either by absorption or scattering. The interaction that happen within the body either is from photoelectric effect, content effect, or effect productions. Firstly, that content effect and photoelectric effect are producing the recoil electron and photoelectron. These two electrons are responsible to cause further ionization and excitation, and also producing another radiation which is called as Bremsstrahlung and delta ray. Okay, these absorbing materials, this one, that been caused by recoil electron or photoelectron. What are effect of these two electrons is actually transfer energy to absorbing materials, that is contribute to what is meant by transferring energy to absorbing material. It causes absorbed dose to that particular tissue. So the one that contribute to absorbed dose to the patient is coming from recoil electron and photoelectron. By how? By transferring its energy during its travel within the absorbing materials until it becomes rest. So during the travel, it can be either radiative loss, where it produces the Bremsstrahlung radiation, or it can be producing ionization and excitation of the atoms, and also it can produce another ray which is known as delta ray. Okay, I think that's all for interaction of electron with the matter. All right.